allegedly the joke is only funny in 7 countries. Can you name the 7? Good. Okay. I want to say it's something like it's like Morocco or something like that. Bahamas. And Cayman. Puerto Rico. Puerto Rico doesn't even do it? Because it's a territory, I suppose, yeah. And you know why the Marshall Islands are? Because basically the United States rebuilt them after World War II. We used them as they were a major base to get to Japan. There you go. Learn something new every day. We gotta learn that. Girls, have you ever flown in a plane? What did I hear? Random factoid of the day yesterday was 80% of Americans have never flown in a plane. And I thought that's way too high. But then at the same time, I'm like, okay, maybe. I trust anything on the internet. I don't know if you saw the facial expression. No. But that was like the stat of the day. That might have been a Facebook reel. Oh, whatever. Okay. So you've been in a plane. You do realize that the pilot has to, kind of aim the plane, right? Okay. Right? Do you know what they call that aiming of the plane? No? That's called a bearing or navigation. There's, in some planes, in the olden days, there used to be 3 people in the cockpit. There's the pilot, the co-pilot, and the navigator. Okay? Because before computers, people had to figure out where they were going. They had to actually maps. Okay? Alright. So we're going to learn navigation today. Okay? And we're going to take things, we're going to tip it on its side, we're going to spin it around, and then all of a sudden, again, splash zone. Okay? Okay? So, with that being said, let's talk, in your note packet, let's talk navigation. So first off, unit circle is math. Okay? The unit circle is your math angle. Okay? Navigation is different. Notice, big underlined. I don't think we bolded it, but it's underlined. It says all angles are measured from the north. On a map, north is up. Okay? Which means south is down. And then I always remember it because it spells we. West is left, east is right. Okay? So when we are navigating, when we are giving a bearing, when we are getting a heading, okay, our north is 0 degrees. How is that different from the unit circle? 0 is straight out to the right on the unit circle. So right away, that's it. Sorry. Okay. The other thing is that positive angles are drawn clockwise, which means that east then is 90 degrees. South then is 180 degrees. West is 270 degrees. And there is no 360 degrees in navigation. It's not like the unit circle where 0 is also 2 pi. 0 is 0. So it goes 358, 359, 0. Okay? You cannot have a bearing, a navigation, or a heading bigger than 360 degrees. Okay? So you can't have, I'm on a heading of 715 degrees. Okay? You can't have it between 0 and 360. Okay? Right? Now, with that, so that's the tipped it on its side and spun it around. Okay? With that comes multiple ways of naming an angle. So now we can have a navigation angle that then we have to convert into a math angle if we're going to do some calculations with it. That we also could convert into a reference angle, because if we have to find certain angles, we're finding reference angles. Okay. That tomorrow we're going to have, in the goofiest of goofy ways, west 30-some degrees of north kind of a deal. Yeah. So after tomorrow, you're going to have 4 different ways to say the exact same angle. Okay? All right? So let's try some. So first off, whoops, tap the brakes, I missed. So here we go with a 53-degree angle. So I want to figure out all of the different things all of the different ways that we can do a 53-degree angle. So they come out of the north. So, and then I would go down 53 degrees for my navigation angle. For my math angle, I'm going to convert that back into from 0 on the unit circle. So what would the math angle be, or the trig angle, if you will? $27? $37. How'd you come up with that? And I also have the reference angle. Now, one thing that I forgot to mention up here is that our reference angles are still off of the horizontal. And our math angles, or our trig angles, we call them both, are off the unit circle. try one here now with 195 degrees. For this one? Oh, sorry, at 30 seconds, because it's in quadrant 1. It's the same as the math angle. Sorry. Thought I had proved that one. (195 degrees) for a bearing angle and navigation angle would be here. What would the trig or the math angle be? Anybody? Trig or math angle? I get 255 degrees. Speak now. Okay. Where's Eleanor? Where's 195 in a compass rose bearing angle? You agree with where 195 is? Okay. So how far is this then? How far is this then? 180. So how big is this angle right here? 15. So now my math angle goes that way, right? So if I'm on the unit circle and I start here, I go 90, 180, 270, but I got to come back 15. So 270 minus 15 is 255. What is my reference angle? It's my reference angle. Nope. It's an acute angle off of the horizontal side, 75. That, I know it's been a couple of weeks since we've talked reference angles, but nothing has changed from our reference angles from when we did it earlier. Okay? You try the next two. All right. That's off by a little bit. 300 bearing, so that's my nav angle. So that's going to be that way. That's my 300 degree angle. which means that my trig angle, or my math angle, is going to be 150 degrees. Because my reference angle is 30 degrees. Agree? 300 degrees, you got to go through 3 quadrants. That's 270. You got 30 left over. So your reference angle is going to be 30. Which then you subtract and you get 150 from that one. 300 that one. But 127 is going to be here. That's my navigation angle. My trig angle is going to be here, or my math angle, if you will, is going to be 323 degrees. 360 minus 20, no, minus 30 is 323. Yes? My reference angle is here. It's 37. Yes? All right. Let's get into it. So, when we're dealing with navigation, navigation is different than statute distances. It's goofy. It's I don't understand it, but it is what it is. Okay? So navigation uses things called knots or nautical miles. Okay? A nautical mile is, if you take unit circle here, and this is the outside edge here of this unit circle is the equator. So you chopped the Earth in half. You samurai sworded it from the outer space. Okay? Are you with me? So you take that and you divide that up into 360 parts. Okay? One of those parts now is a degree of the equator. Okay? You take that single degree and you break it up into 60 parts. So now you're at 1 minute of the equator. Okay? 1 minute of the equator is approximately 6,206 feet. Don't ask me why I know that, okay? But it's approximately 6,206 feet. That is the length of a nautical mile. A nautical mile is 1 minute of arc length on the equator. Okay? That means absolutely nothing for you, I'm sure. But just so you know, when you hear that a ship is sailing at a certain amount of knots, that is nautical miles per hour, which is different than your car driving to and from school. That's miles per hour. A mile is 5,280 feet. A nautical mile is 6,206. I think it's 6,206 feet. Oh, 6,076 feet. I was way off. I apologize. My fault. 6,076. Okay. So a speedboat travels at a speed of 40 knots. So that's 40 nautical miles every hour is travel. Just like miles per hour, but it's a different, not miles. Okay? All right? From Fort Lauderdale. Fort Lauderdale is over here. Okay? It travels at a speed of 40 knots on a course of 65 degrees. So what I would recommend you doing is I recommend you putting a little hash mark, or not a hashtag, target, crosshairs. Big crosshairs. Okay, you put a little crosshairs right there because now you're traveling at a course of 65 degrees. So that means that this angle right here is 65 degrees. It travels on that course for 2 hours. If it traveled on that course for 2 hours, how far did it travel? $80 nautical miles. NM is nautical miles. Okay. Then it changed its course. All right, well, it changed its course. Let's get another crosshairs going on in there. Now it changed its course to 155 degrees. Where now this angle here is 155 degrees. It traveled on that course for 4 more hours. How far did it travel? If it was traveling at 40 nautical or knots, how far did it travel in 4 hours? Traveling at 40 knots, 40 nautical miles per hour for 4 hours, it traveled 160. The problem is asking to find the distance that it is from Fort Lauderdale and the bearing from Fort Lauderdale to the boat. The boat is now there. Excuse me. Okay. What do we know? Tell me some things that we know. Okay. Give me one of the angles that we can find. This big one? Okay, let's zoom in on that one. What is this angle right there? The measure of the purple angle. And why? I'll give you the y if you give me what it is. Because it was kind of funny listening to the last class to figure out why. We got it in. It is 65 degrees. Do you know why? I'll give you the attempt. What? Man, nailed it. It took the last class like 5 minutes. They were coming up with complementary, supplementary. There were some weird ones that they said that I'd never heard of. But yep, so that one here is 65 degrees based off of alternate interior angles. Love it. Okay? What's the measure of this angle? The green one now. How much? 25? How'd you come up with 25? How do you know it's 90? You don't know it's 90. You don't know it's 90. How did you come up with 25? I would agree with 180 minus 155, yes. Now that we know one part of it is 65, the other part of it is 25, now we know that this is 90 degrees. We can't assume that it's 90 degrees unless we know for a fact or it's been given to us in the problem. Okay? So now we know. So now this is what kind of a triangle? Now this is a right triangle. That makes things easier for us. Okay? So how can I find side length x in a right triangle? We use that Pythagorean theorem. Yep. So this is going to be 80 squared plus 160 squared is equal to x squared. 80 squared is 6,400. 160 squared is 25,600. Add those two together and you get 32,000. So if I take the square root of 32,000, I get 178.8854. Agree with that? So the boat is 178.9 nautical miles bearing. Now we got to find an angle, right? Which angle do we want to find? Left or right? It does make a difference. The problem says that we want the bearing from Fort Lauderdale to the boat. So is that the left angle or is that the right angle? The left angle, because here is Fort Lauderdale. So we need to find that angle there. It's a right triangle. How do I want to find that angle? right triangle, how can we find that? So Kato, which one do you want to use? Do you want to use so, ka, or to? Cosine would be using the hypotenuse, correct? Which has already been rounded. Tangent would be the best. Yes. So the tangent of theta is equal to the opposite side divided by the adjacent side. So theta then is going to equal the inverse tangent of that. That is going to give me 63.43495 degrees. What is the bearing? So let's say the boat, we run out of gas in our boat. Coast Guard's got to come out and get us. One, we're going to be waiting for a while because they got to travel 178.9 nautical miles. But two, which direction do they need to head in? What is their bearing to us? How did you come up with that? So the bearing that they're heading to us is going to be this big angle right here. And that's going to be our original 65 degrees plus 63.43495 degrees is going to be a bearing of 128.4 degrees. And then I have to add in that this is from Fort Lauderdale. Not from the boat. We're on the Fort Lauderdale side of our triangle. Okay? Let's set this one up, and then I'm going to have you try it. So, a shoreline runs north and south, and a boat is due west of the shoreline. The bearings of the boat from 2 points 300 feet apart on shore are 240 degrees and 260 degrees. Those 2 points are known to be 300 feet apart. You need to figure out how far the boat is from shore. Go. So that means that this angle is 60 degrees. This angle is 80 degrees, which means that this angle is 100 degrees, which means that this angle is 20 degrees. This angle is 10 degrees, not that we need it. That. Now, but I can utilize the law of sines, now that it's a tool in our toolbox, to find my red or blue, I don't care which one, red or blue sides. And I'm going to go for blue. So the sine of 60 degrees over my blue side y is going to equal the sine of 20 degrees over its opposite side, 300. That's going to give me that side length. My blue side length is 700, oops, not 29. Going to give me that. Now I'm in that bottom triangle, and so I can say then that the sine of 80 degrees is equal to the opposite side x over the hypotenuse, which is the side that I just found. So I could say that x then is equal to that side that I just found times the sine of 80 degrees. Luckily I kept it on my calculator, and so I can get that, and I get x here is equal to 748.0863 feet. So the boat is 748.1 feet offshore. Great. Questions, comments, concerns, clarification? Good. Good stuff.